Hello everyone, welcome back to the channel once again. In this lecture, we are going to learn about the Pareto chart and histogram chart in Excel. Both the histogram and Pareto charts are very similar when it comes to its application. That is, it is used commonly for showing the distribution of a continuous data set. It helps you look at how your data is spread out. Few examples are frequency of cricket score of Indian team, distribution of population by age group, distribution of heights or weights of few people, etc. Here we have two charts. The one at the top is called Pareto chart and the bottom one is called histogram. Both of them are very similar, but when it comes to Pareto chart, we have the arrangement difference. Along with the chart, we have this line which is not in the histogram, and this is called Pareto line. And don't get confused this chart with the column chart. The major difference between the column chart and histogram or Pareto chart is that you see at the bottom, you see at the bottom of the chart there are two values which is called win value, and it makes one column in the histogram or Pareto chart. But when it comes to column chart, you will have only one value making one column. For example, if you have a column chart for sales data of an entire year, then there will be one column for each month. For January there will be one column, and for February there will be one column, and so on. But when it comes to histogram or Pareto chart, a bunch of values or group of values form each column or chart strip. So here we have two different values. See here in this column we are having two different values, 70 and 71. It means that this column is being made by the total figure of any value ranging from 70.1 to 71 or 70.2 to 71. Before I proceed to this video, requesting all the new viewers that this lecture is a part of complete Excel course, and if you have not watched other chapters, check out the playlist and start from the beginning so that you do not miss any important section of the course. And if you have not subscribed to this channel yet, please hit the subscribe button and also hit the bell icon so that you are notified every time a new video is uploaded. Now let's understand this Pareto chart and histogram chart practically in Excel with the help of one example. So here we have a data. In this data, these are the name of the people living in that village or in that town, and this is the height of each people. Here we also have some data on their weights and the age, and we have another table that is a product and sales. So we'll be looking each table separately for Pareto and histogram chart. So the purpose what we have said is that histogram is used or Pareto chart is used to see a continuous distribution of data set. So in this data set, here are multiple numbers of people whose height is same, like 74 is there, here is also 74, and there are 75. So there are duplicate values, as well as there are duplicate values for their age, weight, as well as age. So based on their height, their weight, and their age, we may decide that what kind of cloth, what size of cloth they may require. So I have to keep in my inventory according to the requirement of the place. So if I want to see that what would be the requirement of size L or M or X based on their height or based on their weight, I can decide by creating a histogram chart out of this data. So let's first create the histogram chart based on their heights. So we have to select the data. So here I'm selecting and then Control Shift down. I'm selecting the old data, and this is a data set of 1037 people. Now go to insert and then click on here, and this is histogram. Now let me cut it and bring it at the top of the table. I will paste it here. Now let me put it here and increase the size so that it is clear to everyone. So in this graph, you see at the bottom that there are two data sets. In the bottom there are values. And the one value is 67 to 67.8. So these are given in a fraction. So we can change this fraction into whole number. So to do that, we need to do right click here and click on format axis, and then here in the axis option, instead of automatic, we can select the bin width. Bin is nothing but the difference or gap between two data sets. So here this data set is from 67 to 67.8. So instead of 67 to 67.8, we can make it 67 to 68, 69, 70. So according to our requirement, according to our age difference group, we can set the bin gap. So that bin width will be given. Here it is by default, Excel has given as 0.8. So we will be changing this to 1. Then hit enter, then it will change like this. Now it is 67, 68, 68, 69, like that. So this data is because of the number of people whose height is from 67 to 68. If there may be 2%, let's see how many people are there. There are 9 people whose height is between 67 to 68. And in case of this one, there are 175 people whose height is between 73 to 74 centimeter. So on for this one, there are 27 people whose height is between 77 to 78 centimeter. But if you notice, let me zoom it a little bit and see here, there are two kinds of bracket. One is third bracket. This is called square bracket. This is called a square bracket, and the other one is called round bracket. So this is round bracket. So you might have noticed here that the first data set is given only as a square bracket, but in the second one we are having two types of bracket. This is square bracket, and this is square bracket, and this is square bracket, and this one is round bracket. So why we are having two types of bracket here? So we need to know the concept of this. See, if there is a square bracket, it means that data is included, and if it is round bracket, it means not included. What do you mean by included or not included? Say, let's see, there are some data like 67, 67.1, 68, 68, 68.1. These are the data I'm having, and when Pareto chart or histogram chart is created, it is forming the data range from 67 to 68. So this first chart will include 67, 67.1 and 68. But here 68 is here also, and in the next chart we are having 68. So whether this will be included or not, 68 will be included or not. That is why round bracket is being used here. It means that it is a round bracket means it is not included. So 68 is not included here. Round bracket and 68, it is written as like this. 68 means 68 is not included, but 68.1 is included. Means 68 up to 68 it is not included, but 68 onwards will be included. So here in this data chart, the value of 68.1 to 3 up to 69 will be included, and like that here also 69 won't be included, but 69.1 will be included. So if I am having a data like this, 68.5, 68.7, 68.8, then 69, then 69.1, 2, like that. Then this data, this chart will include this one up to this one, from here to here will be forming in this chart, and this 69.2 will be included in this chart. So you understand the difference between this round square bracket and round bracket. Round bracket is not included the first part, but included from the onwards. 68 is not included, but 68.1 onwards is included. That's why it is being used here. Now let's create another chart. This is called histogram chart. And the histogram chart, you see that this data is being arranged. This chart is being arranged in the ascending order. The value is 67, 68, 69, like that. It goes up to 83. It is in ascending order, not based on this chart. This value may be less, this value may be high. It doesn't depend. Whereas in a Pareto chart, it is not going to happen in the any order. It will be arranging in terms of its total value. So let's include another chart. Then go to insert, then go to here, and then another chart what is there. So let me cut it, then let me bring it here. Here also it is, the data range is from 150 to 150.86. So we can change this one, right click it, go to format access, and then change the bandwidth from 8.6 to, let's see, 10. Hit enter, and it will change like this: 150, 160, 160, 170. So this is also histogram, and it is being arranged in ascending order. 150, starting from 150 to 290. Now from this data we can see that what is the actual number of people whose weight is 190 to 100, 200. So here it is 126 people, and from 200 to 210 it is 103 people. So if we decide that size is weight, the M size, it will be is weight will be between 180 to 100 to 60 to 100 to 150. Then L size, if we decide that 151 to 200, 180 here. Then XL 181 to 200, double XL 201 to 290. So if we decide that this is the actual size of any garment, any apparel, if the person's weight is 100 and 250, then he can wear M size, and if the person's weight is 151 to 80, then he can wear any apparel of L size, and so on. So this is what the standard size. Suppose, then how much inventory I need to keep it? So we can see from here that 190 to 200, 190 to 200 is coming 190, 180, 150, 150 to 100 to 150. So this is only 14. So we need hardly 14 here, and then 150 to 180. So here, from here to 180, then it is coming around 102. So L size will be requiring around 50 numbers. How much? There is 29, 76, and 103, 102. So around 200 numbers it will be necessary. Like that, it may be necessary for 181 to 200, like this. So it is around 126 and 10, so around 250. So like this we can decide how many t-shirts or how many clothes of L size or how many pants of M size or XL size will be required, can be decided based on then this histogram. All right, so now let's see the Pareto chart. In this one we can change this chart into Pareto chart. Go to chart design, change the chart type, and then select Pareto chart. So here, see the bottom line. the data is 190 to 200, 200 to 210, 180 to 190. So it is not in any orders. Here 150 to 160 is coming. So this data is not arranging in the ascending or any order. It is arranging based on the number of people, in that particular group. So here 190 to 200 is having the highest number of people. So it is, this chart first stick is being arranged on the left side. Okay, so it is arranging in that format. And this Pareto, this one is showing the total cumulative value of the data. So all this data is forming 100%, and the secondary axis is in form here. And if we want to see that what is the actual value, means 50% or 40%, yeah, 40% of the total people is, so 190 to 210, 40% of the total population is between the weight group of 190 to 200. So 190 to 200 is for those people who needs double XL size or XL size. So we can keep our inventory 40%, and the remaining 60% we can keep some XL, some M and some L. Like that we can distribute, and that's how we can decide the inventory of our shop. I am just talking about the inventory of any my shop or any shop. We can decide any of our setup based on this data, and that is how Pareto chart and histogram is helping us to decide our problem. Now let's delete this one and let's insert the Pareto chart for this one. Here we are having product 1, product 2, like that up to product 9, and we want to see what is the sales of each one, which one is making most contribution of sales. Okay, so we can do that one using the Pareto chart here and Pareto chart. Here the highest sale is in product 2, and product 9 is the next highest sale, 3, and so on. So if we see from the graph, here is one Pareto line is showing here 50% of our sales are coming from product 2, product 9 and product 3. So we can check that one manually also. Let's go. What is the sum of product 2, product 9 and product 3? That is 25,000, and sum of total is so if we see the percentage contribution of these sales, it will be coming almost around 45, 46. Let's change to percentage. So it is coming 46%. So 46% of my sales is coming from product 2 and product 9 and product 3. Okay, so if I want to improve my sales, then I have to keep more focus. If I want to make some kind of advertisement or marketing strategy, then I will be focusing on this product 2, product 9 and product 3. And if I want to improve the sales of the remaining part, then I will be focusing on the product 6, 7 onwards and whatever remaining is there. So with the help of this Pareto chart, we can decide many complex issues very easily. That is not there. If we have to do like this, then manually we have to calculate like this. So that is a very time consuming, and then with the help of Pareto chart, we can do easily. 70% is being sold here, only 10% is being sold here, and 60% of product is being sold by product 6, product 3 and product 9. 4 products are selling 60%, right? So 40% are being sold by remaining 2. So that is how we can determine from the histogram or Pareto chart. So we have learned in today's lesson about the Pareto chart and the histogram chart and how it can help in our day-to-day data visualization, data management. And I hope you have understood it and like it. And to show your support, hit the like button and share to your friends. Your feedback is also very important for any creator. So please drop your comment. That's it for this lecture. See you in the next video. Take care. Bye.